So, welcome to the lab for the class. You have seen the notes for the class meeting with homework assignment, and we basically will do stuff related to this homework assignment. Right? You do have your emails and just a general context. We are modeling. We are now focusing on the electron encaged in the box, and we are looking onto the dynamical aspects. There are a couple of basic questions that you may answer out loud, or you may just answer in your head, or just postpone. I will bring these questions later, maybe in some form of quiz or exam, or just in a discussion. So, what will be the dynamics if the electron is prepared in the ground state? And anyone online also are welcome to preferably speak it into the microphone if you want to. Would you now you it's like individual thing. Would you see any dynamics if initial state, if you solve time-dependent Schrodinger equation and you prepare initial state in the ground state? At time 0, it is in state number 1. Yes. No. Ground state, the lowest one, is lowest energy. Do you think it will change to in any shape? No, exactly. And it is clear intuitively, but it is declared in the one of the postulates. So eigenstates are those states that do not change over time. Will there be any dynamics if you prepare the electron in a completely excited state, number 2 with 2 humps? Yeah. Will it change over time? No. No. And here is the biggest lie of quantum mechanics. If we accept only those postulates and try to believe in them without doubts, then it will stay in the excited state forever. And it will not change its shape if you are looking on the probability distribution. So wave function will accumulate phase, but the wave function will not be changed. If we, and it's time for probably time to share screen, otherwise it will be too boring, especially online. So if too boring, especially online. So if let me bring, yeah, the thing that we discussed in class. So if we neglect interaction with environment, if we neglect this additional axis, so if everything is isolated, then quantum system in the eigenstate will stay forever without changes. And the feature is that quantum system in the eigenstate do not show any noticeable dynamics. So if we know for sure that in the real life experiment that you want to describe, system resides only in one of the eigenstates, we can forget time-dependent Schrodinger equation forever, because nothing is changing. We do not need time dependence, but it happens very rarely. In realistic situations, often there are superpositions between several eigenstates, and then overall picture depends on time. So we need time dependence if we cannot guarantee that the state will be pure enough, that it will be a mixture of other eigenstates. And the stuff that we are going to run, basically you just run the code that is in the email and make a couple of slides of lab report. It will be basically homework. But the idea is that we may want to recognize difference between eigenstates and superposition of eigenstates. So Eigenstates do not change in time. Superpositions of eigenstates change over time. Okay, maybe enough. Let's read what is in the assignment. Consider electron in one-dimensional box of length. At time 0, it resides in a superposition, ground first excited. Find expectation value of position operator as function of time using attached MATLAB code. So attached MATLAB code doesn't give the expectation value of position operator. We need to do a little bit of coding. Yes. But first, let's run and watch what happens and explore the code itself. So if you just watched the morning lecture, you probably have noticed this little video, right? So it means that there is a probability for electron going from one side to another one, so to say, oscillations. Can you say intuitively what would be the answer for expectation value of position? Would it change over time or will it not? Position. Expectation value of position is where the biggest probability to find an electron. Right, it will just oscillate with a certain frequency and certain amplitude, probably around center. It will be like 0.5 plus something going forward and backwards. So we need to extract the stuff from this probability distribution and add it into the code. So let's watch the code, start running it and see what happens. So I just downloaded it from the mail, pushed the button with a triangle, same as play movie, and then it shows this movie, this how to say, wave functions. If I click space bar, yes, thank you. If I click space bar, it shows square.
Yeah, you don't need to click off.
Thank you. And then if I click once again, it starts showing the movie, right? So suppose that we have 20 people in the class and I do not know personally. So you need just to make impersonal homework report. So then you need to upload the movie to YouTube, but it is not the whole story. If YouTube fails or they decide that we do something that they do not like, support the wrong party, one can just represent this progression of snapshots as two-dimensional figure. And I think it was the subject presented by Kennedy. So if you look here, it is the same thing. It shows the probability distribution at time, initial time, next time step, and then it will be bigger at one side and another one, right? So you may want to copy paste this image into your PowerPoint. One can also do Word, but PowerPoint is maybe a little easier. Okay, now let's explore the code. And I'm suggesting to you because even if we quickly do today's assignment, later on we'll have more and more things. And I assure you, changing a couple of lines in the code is 20 times easier than to derive the same thing by pen and paper. So please let me know if you do not if the font is small, and if probably I shouldn't ask it, I should just references, fonts, just will make it a little bigger. And then anyone on online will also will be seeing it. So we are defining the let's set the size of the box 1, otherwise it will be maybe too much. Then we set range with chopping on 20 time steps, and then this psi1, psi2 are just wave functions that we covered in the class, right? So sine n pi x over L. And then we can plot it. We already saw it, just camel with one component, another one. Then we may want to set up this R 11, 22, 12, 21, which are density for special components that will be used later on. The superpositions of this R11, R22, R12, R21 will be used in order to go from wave functions to the probability distribution. Even if we do not define them, we will need to go over them. They will be there. We just give names to intermediate objects. And here we plot them. So if I remember, if one sets up x and y, and then with comma one can do it x and y once again, x and y once again, and then it does show the set of images. So this with humps up are eigenstates, and two things going up and down are off diagonal. Now we are setting the probability distribution in the following equation. So on my terminal it is line 28. So I'm doing 1/2 plus R11, 1/2 R22, then R12 times cosine of 2 pi time divided by period. So what is this equation? How does it relate to what we did in class? So let me bring it up from the class material so that we see connections. So we are implementing this one, so probability distribution, and this, after we do all things together, it will be here. So maybe I'll just write it. It's a little messy. So probability xt 1/2. So the last line comes from 1/2 rho 1, 2 times e minus I e2 minus e1 h bar t plus 1/2 rho 2, 1 e plus e2 minus e1 h bar t. And then since this rho 1, 2 and rho 2, 1 at time 0 were the same, we can put them outside of the box. We can use eigenfunctions, and then outside of the brackets, and inside the brackets we do have we can put 1/2 also outside of the bracket, e to the power plus e2 minus e1 I t plus exponential minus I e2 minus e1 or h bar t. And then by Euler equation, this thing converts into cosine e2 minus e1 h bar t. Make sense? So it correlates to what we did in class. So this equation is just this coding represents this equation. Now, okay, I think everything we need is done. It's just not labeled. So the good, polite style of programming is to just put a comment and explain everything after each line. I was in rush 3 years ago and didn't went out of the rush mode since. So what I will focus on this equation because later, and this is the main part of the assignment. Main part. And here, let me bring up something. So this line is I'm very clear what it is. I'm just finding the right words. Maybe let's make another empty slide. So at given time, let's say time 0, we've got distribution. And we can funnel it into the variable s. So it will have only this distribution. At time t equals maybe delta t, first step, it will be slightly different. And we can use the value at time delta t and previous version of the variable s as a new matrix to redefine this S matrix that will include like 2 rows and 1 column. If you do step 3, t equals 2 delta t, we are bringing this RR into the updated S by this operation. And now the variable S will have 3 rows and 1 column. And if you do so many steps, it will be square matrix with 1 rows represent position and columns represent time. Now, inside the loop, we just plot the present distribution at given time, make pause, and then as Zane was demonstrating on Friday, we are funneling it into the file. So, and closing the file. Now we have variable s that if you have patience to go over all the stuff, so waterfall s will show this thing, and we do not need to do waterfall. One can do mesh, and then it will show the same thing, just visual appearance will be slightly different. So I think it was a subject presented by Kennedy, how to present three-dimensional images. If you're curious how many rows and columns one can do size as, so it's a matrix 300 by 200 that you just represented. Okay, now how do we find the expectation value of the expectation value of the position? So A equals integral dx psi xt A psi star st, right? If we replace A with x, and x is quite simple function. It's not differential operator, so we can swap. We can put swap order and have psi star psi x integral ddx, expectation value of x over time. So this psi star psi is our probability distribution, right? So we need probability distribution at given time and space, multiply by x, and then integrate dx. And it will be expectation value of position at a given time, right? So let's look onto the line that I did highlight here. So line 29. So AX is for average X. X is should have been defined before in line 12. So it's just a set of values. So we define X numerically. And now by multiplying vector X by the vector of probability distribution, we will get the value of X at given time. Let me check here. Right now, we do not have dx in here. So in order to, in addition to normalization, to have the correct answers, one needs to multiply by dx. And dx will be whatever is set up as a step here. So C, put it x. Control S. So if I do plot RR. So it is distribution at last time of simulation. If I type size RR, it will be 200 elements, same as X. Now, if I multiply X by RR, it gives an error because size X because they are of the same arrangements. They both are rows, and you cannot multiply row by row. But if I set up row by column, if I put apostrophe, then it will give a number. And if I define dx as a step, and if I do this little thing, it will show this number 0.15, which let's do it this way: quote x, comma rr. So it may give some error, but it shows that it is closer to 0 than to 1. So it should be somewhere here, expected value. No? Opposite sign?
Opposite side.
At which time? Oh, that, and I wasn't talking to anyone on the line. I need to ask everyone to share screen. Let me see yours first. You didn't multiply by dx. Or?
If my dx equals
But
over
did
200,
you rerun? Did you rerun?
do I have to rerun?
Yes. If you type things.
Okay. Beauty. Now, can we do? So when you edit the.
When you edit the script, but you do not run it, variables are not automatically updated.
Okay.
I need to multiply by dx here. Dx and save. Control S. Then I might want to rerun this stuff. So I have modified the expectation value part of the code, practicing a little patience, and then I'm doing the same experiment. So 0.15 x times rr times dx. Okay, so since we do not have enough grid points, it still has an error. It should be more precise. It should be bigger value. If we make number of steps not 200 but let's say 500, it will increase the precision. So one more thing. Here I am accumulating this expectation value at each time step. So at time 0, it is empty array, and then each time we come through the cycle, I add the value of this ax to it. So it grows and becomes longer. And now if I plot average x, it shows this thing. So it starts on one side, goes to another one, goes back, goes forward and back. I still need to debug an error. It should oscillate around 0.5, around half. So there is a chance for improvements. But for educational purposes, I will give extra credit whoever find the error. But please, if everything is clear, just please document it, maybe add labels to figures and do minimal explanation. So there is no intention to keep all us here until midnight, just whatever you can do in, yep. So just do a small lab report by copy pasting figures. And I'm going to check in online. So Tim, Spencer, Connor, may I ask you? Let me make you co-hosts, and I'm going to yes. Spencer, make co-host. Yes. Tim making co-host. Yes. So may I ask you to start sharing your screen and show how the code is working? Because sorry, I wasn't looking at your activity, but now it is time.
Are we all done? What do we got more?
No, no.
We're all good?
Just and it is due by Monday. Yeah.
Yes, sir.
Thank you. So let's go just as you guys are appearing in the line. So Connor, would you like to be the first? And I do not hear anyone. Connor? Please consider to share screen.
Yeah, I'm working on it. For some reason, it won't let me share my screen. Oh, I think it fixed itself.
Maybe. Oh, okay.
Wait, can you hear me?
Okay, excellent.
Thank you.
Can you hear me?
I will bring
Okay. Wait, hold on.
speaker. No, speaker should work.
Wait, can you hear me? I'm talking.
Okay. Would you please show the? Just a second. I will check the chat. No, I cannot hear you. I do not know why. But if you just show things, it could be sufficient. We'll, if things do not work, I will connect to audio by the phone. So would you please show the image screen?
Okay.
Not right now. I see your control panel. Yeah, plot average x, and
yeah, mine
should be a panel with the image.
Oh.
For example, if you would share the whole screen, not only with one panel, it will pop up. Okay.
Oh, okay. What?
Okay.
I just do.
Can you double click on the x-axis? No, everything looks good. I just double click on x-axis. No. Let's go back to the command line, and type there axis, AX. Now 2 round brackets, open and close round, open and close, and inside round brackets, rectangular brackets, open and close, open and close, and inside this rectangular brackets type 0 space 200 space 0 space 1. Enter. Okay, yeah, I see. So your time progression went not very far. Let's click on the code. Let's click on the code.
Yeah.
Not the image, but yeah. Wait, where you are is good. So I'm looking on line 27. 4 t equals from 0 t capital divided by 100 to 3 times t. Sine 2 pi. It looks like the thing didn't went to the end. Let's change 3 to 10. In line 27, yeah, make to 10 periods. Okay, save, click save, and rerun. You can just click on the triangle stuff. Click on the triangle.
Can't.
On the top, on the top.
I can't.
Upper. Yeah, that triangle, it was correct. Under the letter view. No. You cannot. Interesting. Then close figure. No, you should be able. Zoom blocks it whenever I try to do it. Yeah. Oh, okay. It works. I meant this one. Okay. And now push space. Push space once again. Now we practice patience, so it will go forward and backward 10 times. I know it's a little exhausting, but one can relax while it goes. So it went like 3 times. Maybe previous time you did stop it or something happened. Let's wait until it finishes. So it was about 6 times. 7.
Jeez.
8. And 9.
God damn. It's like a 2 minute long process.
10. So if I am okay, probably I am bad in arithmetic. It's I miscounted. But just let's wait until it is finished. Okay. Now yes, and now push once again. Yes. Okay. So this image is expectation value of position over time. There is a little error that we need to fix. It should oscillate around 0.5, but since I was providing code, I cannot punish anyone for my errors. If you find the error and fix it, you'll get extra credit. If not, you'll get full credit anyway. So please, everything works well. Please copy paste images from each stage into Word or PowerPoint and write some comments like what you observe, how do you interpret it, and how does it answer the main question. Make sense? If okay, then you are welcome to stop sharing screen, and we'll go with Spencer. Would you like to share your screen? Yeah, thank you. I'll try to change the speaker and see if you try to say something.
Yep, can you hear me?
No, it still doesn't go.
Wonders of technology.
Try to say something. No,
I did.
doesn't help. Okay, but I think we can interact just by visual. So when you see this image, can you show the image that you were demonstrating? Yes, push space. Push space again, and just wait until it bounces forth and back. If you were not modifying, then it will be only 3 times. And the last one, 2.5, and 3. Now push space once again, please. So it shows this waterfall, and push space once the last time. Oh, the one in your case, I don't know, you probably corrected or you used not corrupted version, but it oscillates around 0.5, so it is perfect. So it makes complete sense. So nothing to improve, just copy paste this image and previous images into PowerPoint and write minimal comments that will help to understand what is going on. So I think, okay, yeah. Thank you. And now the next is Tim. Tim, would you please share screen? Oh, thanks for warm words, you too. Okay, and just let's run this stuff. Yeah, push once again. Yeah, push. Yeah, now let's practice patience. And push enter, not enter space once again. And you have this expectation value of position over time, right? So it oscillates. And as we discussed in the class, it never comes really to 0 and it never comes really to 1. So it doesn't touches the walls. It starts reflecting before it approaches the wall. But please copy paste these images and write explanations and make sure they just make connection between these images and what is being asked for the homework assignment. Since something is going on with the voice, please type questions if any, if you have any questions. And if there are no questions, okay, yeah, then thank you, Tim. Then everyone is welcome to disconnect and depart. I think we are done for today. So wishing you a relaxing evening and see you on Friday.